Hello, my name is Julien Salleyron. I'm a distinguished engineer at Traefik Labs, and in this video I will explain you how works the traffic cop. The goal of this is to help you if you want to contribute to traffic, if you want to make some pull requests about bug fixes or enhancements. And today I will talk about providers. And as an example, I will show you how works the Docker provider. A provider is a component that connects to your orchestrator API, listens to all the orchestrator events, and creates a dynamic configuration. And this dynamic configuration configures the reverse proxy. It configures, for example, routers, load balancers, middlewares, or TLS stuff. Now let's go into the code. To create a provider, you need to implement the provider interface. The provider interface is in pkg, provider, and in the file provider.go. The provider has two methods. The first one, init. Init is called in the provider aggregator to initialize the state of your provider. And then you have the provide method. The provide method provides a dynamic configuration to the reverse proxy. Provide method takes two parameters. The first one, a chain of dynamic message. This dynamic message is a dynamic configuration and the provider name. The second parameter is a safe pool. The safe pool is a mechanism to launch some Go routine. Now, let's go to the Docker provider. So, as you can see, the Docker provider implements the provider interface. We have the init method. And in this method, we just initialize the Go template to handle the default rule you configure on your provider. And then we have the provide method. First thing we do in the provide method, we launch a Go routing using the safe pool. The safe pool will handle the life cycle of your Go routine. And so when we will want to stop the provider, the routing context will be done. And so you will be able to stop everything you start in your provider. Then we create an operation and we use a retry mechanism to retry the operation if the operation returns an error. So for example, if your Docker client failed, we will retry to connect to your Docker API. In this operation, first thing we do, we add some field in the logger, like the provider name to Docker. And then we create the Docker client that will connect to your Docker API to retrieve the data we need. Here, we get the server version to put it in a debug log. And then we will create the Docker data. The Docker data is a simplified version of the container data from the Docker API. Here we can see that we have two modes, the swarm mode and the container mode. In the swarm mode, we will call the list services to create all the Docker data. And then in the container mode, we will do list containers to retrieve the Docker data. After that, we call the build configuration, which will create a dynamic configuration from this Docker data. And then we send a Docker message to the configuration chain with the configuration we build and the Docker as provider name. This is the first configuration we send to Traefik when we start Traefik. Then after that, we will watch for configuration change. So in the swarm mode, we will use a ticker. And so every time the ticker tick, we will list the services, build the configuration, and send the configuration to the configuration chain. And in the container mode, we will just connect to the Docker events, and each time there is an event that just start a container or a container that die or a change in the else status, we will call the stop handle that will just list containers, build the configuration, and then create the dynamic message and send it to the configuration channel. Now, what do we have in the build configuration? In the build configuration, we will loop over all the containers we just get from the Docker API. The beginning, we just add some field in the log for the container name, and then we call the keep container method. In this keep container method, we will filter all the container we don't want. So here, for example, we will just keep the containers that are enabled. Here we will filter the container with the constraint you configure on the provider, and we will see if the constraint match the labels of the container. And if it's not, we will ignore it. Here we will ignore all the unLC containers. Then we ignore all the container we don't want, and so we go to the label decode configuration. This will create a configuration from the labels you define. So you will only have the value you define in the labels. After that, we will fill all the other fields in this configuration. First of all, we will verify if you define any routers, TCP routers or TCP services. If you configure one of these, we will just build TCP service configuration. This will fill the services in this conf from labels. You can see we verified. If you didn't define any services, we will create an automatic services, a default service for this configuration. And here you can see a default service and a default load balancer. Then we will loop over all the services you configure, and we will add the server on the load balancer. In this, we'll get the IP and the port you configure, and we will just put this in the address of the servers in the load balancer. After that, we will do the same for the routers. Here, as you can see, we will loop on all the routers you configure. We will verify if you configure a rule on this router. If it's not the case, we can't calculate a rule for this TCP router, and so we will delete this router and just put a log on the router. Then the same with the service. If you didn't link any service to your router, we will try to link automatically a service. For this, we will verify. If you configure only one service, we can do it. If not, we will delete this router and add a log. And if it's the case, we just put the service name on the router. Then we do exactly the same with UDP routers and UDP services. And after that, we will do the same with HTTP. But before that, you need to know that if you didn't configure anything on your container, we may create default HTTP routers and default HTTP service. But if you configure TCP or UDP routers and you don't configure anything on HTTP, we will not create default HTTP things. So here we will just stop the parsing configuration if we see that you configure TCP or UDP without HTTP things. So here we want to create the HTTP service and router thing. First of all, we do nearly the same as for TCP and UDP. We will just create the HTTP service. So if you didn't define any services, we create the default service with the default load balancer. And after that, we loop on all the service to add the server on the load balancer. After that, we go to the build router configuration. So the same as for TCP and UDP. But with a little thing added is the modeled and the default rule template. Because here we will verify if you define routers or not. If you didn't define any routers, we will just verify that we will be able to link the service to the router automatically. So we need only one service. If it's the case, we create a default router. And then we will loop on all the routers you define. We will verify if there is no rule. Here we will not add an error, we will just try to calculate a default rule by using the default rule template you define on your provider. So here we apply the model with all the labels to this Go template and we will get a rule. Then we will do the same verification as for TCP and UDP. We will verify if we need to link the router to a service, and if it's okay, we verify that we can, and we do the link if it's possible. So here we have a configuration field with all the automatic field and with the labels you define, and we put this in a map of string of configuration. This configuration is for one container, okay? So when we finish to loop on all the container, we will take all these configurations and we will merge this configuration. What do we have in the merge? The merge will merge all the configuration we have for each container to a main configuration that we will be able to send to the reverse proxy. So here we initialize an empty configuration. Here we initialize some variables to deduplicate the component. Here we sorted all the configuration to have something reproducible, and then we loop on all the configuration. For each configuration, for each container, we will just loop over all the components we have in it, for example here services, and we will try to add this service to the main configuration. For this we call the add service. In the add service we will verify if there is no service with the same service name, we just add this service in the main configuration. If we have the same service name, we will see if this service is mergeable into the main configuration. And if we can merge, we will just add the server to the servers in the load balancer. This code here is for the unicity of the servers. After that, we'll do the same for routers. So we will just loop over all the routers and we will try to add the router to the main configuration. For the router, it's simpler because we will just verify if it doesn't exist, we add it. If it exists, we just verify that the same router name just identifies the same router. If it's not the case, we return false. And with this, we are able to know if we need to delete this router or if we can keep it in the main configuration. After that, we do the same for TCP services, TCP routers, UDP services, UDP routers, and middlewares. And then we loop over all the components we want to delete because of bad duplication, and we just add a log to say we can't define this component because we have multiple different configurations, and then we delete the component in the main configuration. And at the end, we return the configuration and we will send this configuration to the reverse proxy. So you can see that a provider is simple. The provider connects to your orchestrator, retrieves the data, and creates a dynamic configuration to send to the reverse proxy. Thank you for watching and see you in the next episode. Bye bye.